Hi friends, today we will be discussing about a software called Instinct, which is developed by IIT Bombay. This is basically a software designed for developing microgrid systems, which is basically a PV battery based system. This video is regarding how to get it started, how to install it, and what are the files you need, what are the file modifications that you need to do, things like that. So let's get started. So if you see, the link will give you a file like this, and you might need a normal extractor. You can use WinRAR, WinZip, or normal Windows unzip. You can actually extract the data. Inside that you'll find three files. Okay, one is around 84 MB and others are actually very small. If you see the type, one will be a CSV file and another one will be a Microsoft Excel worksheet. So, and the third one is actually the installer. So install it and follow the screen. I have already installed it, so I'm skipping that portion. Sorry about that. After installation, you will find a cursor like this, and you can click on it. This will be our front end of the software, Instinct. So Instinct is basically an instrument to design sustainability through improved and competent technologies. So for this to work, there are certain prerequisites, that is the data. So if you're having a data with you, like a 24-hour data in CSV format or an Excel format, you can load it using this. So let's see how we can do like that. Okay, so here you can select if it is from Excel you want to do, you can select here. CSV you want to do, you can select here. So now let's see how you can make a CSV and an Excel sheet which is compatible with the software. So CSV is basically a comma separated value file which will be opened in text notepad or textpad, whatever you call it. So you can give the 24 data in row, just give the data what is the power at that point for the 24-hour of the day, and then close it. Then you just pretty much have to load the CSV from here. Click on it, it will automatically load the data. Now let's see how to do it using Excel. Excel is a little more complicated. So if you open the Excel file, you need a Excel thing. So if you're having an Excel sheet, there are around 4 sheets in that, and the first one is info, the second is data, third is installation, and fourth is result. These two are actually not used in the current version of the software. So in the information tab, you can give the name of the rendering, whatever name you want to give the simulation, and the location, Mount Abu, it's a Mount Abu data. And my data, if you're logging the data, if you know that it is what is the interval, most of them use 10-minute interval, and some higher resolution one will use 1 minute data. So my data is actually 1 minute interval recorded, so I am giving it 1 minute. Grid reliability gives you how reliable the grid is. That means if it is 100%, you don't even need a microgrid. You can completely rely on the grid. And if it's 0%, it is basically an independent system, which we will come onto that later when you're doing simulation. And you can give what is the probability or what is the range of reliability of your grid. So here it shows that it is around 70 to 100%. If it is coming to 100%, we will not be requiring a microgrid. That is the system. GPS coordinates and altitude is just extra data which is not necessary at the moment. Battery specs, already we are having its a percentage efficiency, it's all preset, let it be like that. And the solar panel, if you know what is the panel you are using, you can actually select it, but already the database is already filled in, so this area is pretty much not necessary. The second thing is about data. So whatever data is there, you just have to copy paste the data here. So I am having around 1 minute data for the entire day, so it is a very huge database. But my software, the software only uses 24 data points, that is hourly based 1 day data, 1 hour 1 data. So we need a facility, we need a converter which actually converts that. For that we use the software, this system. So let's see how it does this. So I'm having this simulation data. Let's close that. Simulation data, you click on it, it will automatically load the power, and now it is processing and normalizing the data for 24 data points. Okay, so if you see closely here, it is the data points. If you see the graph, this is how the data looks like. So the peaking is at around 14 kilowatts, sorry. So that is a peaking area. All right. So now to load this data into our software, click on set 24-hour data. It will take a little time because it has to open all the resources, so you might have to be patient to open it up, depends on the speed of the computer. So now we have given the probability percentage between 70 to 100, so it is taking 74%. So that is why this is the region of interest. This is the region at which we will be using microgrid. So if you are having an independent system, that is, this case is actually independent system, so you can use 0% and select the data. Okay, after this you can choose the battery if you know what kind of battery you want. Basically in normal operations or normal systems at the moment we use VRLA, that is a valve regulated lead acid, normal lead acid batteries. So let's do that. Days of autonomy means how many days you want to back up the system. So for example, if you want the system to work for the one entire day without recharging, you can give this days of autonomy as a 1. So if you want 5 days to it to be working without recharging, then you can give it as 5. So usually it is 1 day because we are having solar power after 1 day, so that is a recurring period. So it's usually we give it as a 1. So if you want to slightly oversize the system, you can modify this also if you want. So after that you will get what is the energy required by the batteries, the energy during the grid, and reliability. So this is around 96.45 kilowatt hour of batteries needed for this particular system, and 62.42 kilowatt hour of grid reliability energy is the demand of the system. So this particular load profile. Okay, so after that go to the next stage. This is the load profile processing stage, and the next stage will be energy analysis. So it's already calculated. So if you look closely, we have around 98 different type of database for different type of panels, which is monocrystalline, polycrystalline, and thin film. So we can choose between them, and this is one of the best one, 250 watt panel in the particular database. So we have better panels at the moment, but that is not there in this database. So maybe in the further updates we can actually include that also. So it gives you how many number of PV panel modules are required for the current system. That is around 68 panels are required if we are using a monocrystalline 250 watt panel. And it also gives you what is the land area required by the panels. That is 114.24 square meter of area is required by the panels. It also gives you what is the mass, total mass of transportation for the entire panels. It's coming around 1.33 ton. And these are all actually energy data, what is the energy consumed by for the production, for different type of components. This shows the energy analysis of the battery. So we have a payback period cycles. This is the cycles, how many cycles you will get the energy back, and this is inverter and converter energy analysis. A rating of the inverter is given here, that is 20 kilowatt for the particular system which is being designed, and this is the rating of charge controller which is designed for 20 kilowatt, and you'll get the energy payback in here, like it gives you around 2.6 years, which is pretty good. And net energy ratio should be higher, so it is pretty high. If it is above 3, you can say it is pretty good. And energy payback period should be lower, which is also pretty good, which it's around 2.5 years. So that's also pretty good design. So the next is life cycle cost analysis. So in this one we will get the distribution of the costing according to the service life of the thing. So this is annualized life cycle cost. So this is BOS, balance of system ALCC, battery ALCC, PV BOS maintenance percentage. Battery maintenance is almost 0 because we have given it as 0. That depends, if it is a maintenance fee battery, then you don't have any maintenance, so we can give it as 0. PV ALCC is a photovoltaic, that is a solar panel ALCC. So after that we can actually go for the final stage of the software, which is environmental assessment. So once we click on it, it takes a lot of resources, so it will take a little time to load. So it shows you what is the demand, what is peak demand, energy autonomy period, which is all taken from the first load profile processing area. This is where we have given all the information. So if you go back, this gives you what is the number of panels required, which is also taken from the other side, which is energy analysis thing. So after all, we get what is the total PV CO2 emissions, that is how much PV is being generated, how much CO2 is being generated while PV is being manufactured and transported. So this is around 35 ton CO2, and battery is around 23 ton CO2, and inverter plus charge controller emission is around 0.58 kilogram CO2. That is very low compared to these two. And the transportation, we can actually choose between road, sea and air, and in each we'll have different options. What is the number of wheeler, it's like a truck or a auto rickshaw. So using that we will get a fuel emission as 114.89 kilogram CO2, which is also comparably low as compared to the PV emissions and battery emissions. So the total cradle to gate, that is cradle to gate means from production to the final destination, what is the amount of kg CO2 generated by transportation as well as production, that will be given by cradle to gate emission. So that is around 58.265 ton CO2. So after that we will get an emission factor which should be low, less than 1. So it's 0.26, which is also pretty okay. We should go which is also good. Okay, so this is the final energy analysis and report. So this gives you all the information about the sizing, the characteristics, everything about the particular design system. So mainly name is just instinct simulation, that is a common name. So the important thing is, from this reliability 0 means independent grid. This microgrid is designed to be independent from the grid. Load energy demand, battery technology used, what is the amount of battery capacity, panel type used, panel number of panels, weight, land area, that is 114.24 meter square of areas required by the particular system, charge control is 20 kilowatt, inverter rating is 20, cost per kilowatt hour is actually the unit electricity cost, which we got from the ALCC process, that is this one. We got it as 20.76, and if you see the report, it will be reflecting the same data. And energy payback time, we got it from the energy analysis tab, and net energy ratio is 4.9, net emissions 58,265 kilograms CO2, and emission factors around 0.26. Here, this is a guide for a technician. If the voltage of the system, how many number of parallel string of batteries required or series string of batteries required, is just a guide for laying the batteries. So if you know the voltage of the system, usually it is 48 or 24, because if it is a higher power system, we go for 96 or 240 volt. For a very small household application, we go for 12 volt. For a typical house, we go for 24 volt, and for a higher power, we go for 48 volt. So for this particular system, let's take it for 24 volt, and the battery voltage, the battery's voltage, the output voltage, usually we get for 12 volt, which is a standard battery voltage. So we have a variety of voltages, which is 2 is available, 2 volt batteries are available, which is having 2 volt 200 Ah batteries are available, 6 volt batteries are available, 12 volt batteries are available, and 24 is industrial grade batteries, so that is not commonly available, but use 12 volt batteries usually at household applications. So let's select 12, and the AH preference means what kind of AH batteries would you like to buy, because that is a serious choice, because this AH determines what is the pricing of the batteries. So if you are going for higher AH battery, it will be expensive and heavy. So what people do is we optimize it to around 100 or 150, so that it is easily changeable as well as it is cheap. So if one battery goes off, we can actually replace with a cheaper battery. So we can select around 150 AH battery. So you get the information that there are 27 batteries is required, but there is a problem. So if this is a 27 battery, we have a 2 in series and we need around 14 in parallel. That means we need one more battery to complete the string. So this is the revised battery capacity, that is 28. We need to buy 28 batteries. So the revised capacity will be around 4200 Ah, where 4018.76 was necessary. We are oversizing to around 4200 Ah because of a necessity that we need to compensate for the voltage of the system. So we have around 0.04% of additional oversize and additional available capacity of 181.24, which is pretty okay. So if you can play around with the AH, you can actually find out a portion where we can actually avoid the oversizing. If you look into the percentage of oversizing, you can actually see how much is being oversized. So see, now there is no need of additional batteries. If you're using 750 Ah 12 volt batteries for this particular system, we do not need any additional batteries. So we can play around with this. You can choose your priorities, whether you need higher capacity, whether you need a little additional battery capacity is okay for you, then you can go for that. So it gives you all the information regarding this. After that, we can generate the report. So it asks you where you want to save the report. So now I am saving it into the desktop. So this is a randomly generated file name. Save it. Then if you find that file, let me close all the tabs for you. So it looks like this. It's a text document, so you can read anyway. So it gives you information it's a report information which gives you all the necessary details required for the particular simulated system. So that is the main process which is being used for instinct simulation. There are a few more processes that is to be discussed for the software, which I will be showing in the future videos. Thank you.